Okay, we're in section 70 of the notes now. Contents to get through, examples to look at, and then exercises to work on to reinforce what you're doing. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells Advanced Course in Algebra, which dates back to 1904. This PDF that you're looking at has been prepared for the Prison Mathematics Project. I realize there's teachers and students looking at this document on YouTube possibly, and they might be interested in getting a copy. All I can say is it's not published yet, but if you want, you can email me. My email address is Bannon, that's B as in boy, @NNON.US. All right, so if you look at the contents over here, the contents are about the geometric progression or sequence. So, certainly I would recommend you read through that. I try to summarize what he's talking about, and certainly I'll go through the examples the way I would go through them. It may look different than what Wells does, but really the same thing. The two big formulas that were derived in this section were, AN and SM, which is the nth partial sum. So, again, if it's geometric, the sequence is going to look like this over here. A1, A2, A3, yada, yada, yada. It goes on forever. And the bottom line is they differ by some common ratio. And we call R to be the common ratio. So I would say that, A1 is just A1. And then I'd say A2 is A1 times R. And R is a common ratio. And you could play this game for a very long time, but I hope you realize that, if you went to A3, it would be A2 times R, which would be A1 R squared. This is where this formula is coming from. You start to realize that the power here is one less than this index over here. So a 2 gives you 1, 3 gives you 2, AN would give you A1, and then the R would have n minus 1 factors in it. All right? We derived the sum in that section over there. I want to briefly go through that with you. And by that, what I mean is I want to just briefly talk about the way I would derive it. And there's many ways to do it. Let me erase this business over here. Erase it over here. I'm going to derive that sum formula for you now. How do you do that? Sn, I'll write this down for you. This was known as an nth partial sum. I'm just going to call A1 A now. Just easier for me to write it down. So it's A plus A times R plus A times R squared plus yada, yada, yada. And I want to get to the nth term. And what's the nth term? It's this guy over here. So what's going to be? It's going to be A times R to the n minus 1. All right, I'm going to get my eraser out. Erase this business here. Erase this over here. And what I'm going to do is I'm going to multiply both sides by R. So you get R Sn equals, A times R. Yeah, I'm lining them up for a reason. A times R, which is AR squared, plus yada, 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 yada. Well, I'd get A times R n minus 1. And the last term you multiply by R, you get A R n. What am I going to do now? I'm going to subtract. And we'll get the formula they have there. So it's going to be, let's see, Sn minus R Sn. Whoops, sorry, I put the n there. I would get A. And these guys all disappear. Everything disappears except for A, and then take away A, R to the n. By the way, some people question why you're using this R and not this R. To me, the other R looks difficult, so I'm not going to put that down. All right, I'm going to factor out an Sn now. And you would get 1 minus R equals A minus A Rn. I would divulge, I'm sorry, I made a mistake. It's SR is factored out. I don't know why I put equal sign there. So what do you get? Sn would equal, well, let's say you get A minus A Rn over 1 minus R. In the text, they factor out the A. At least I believe they do. They would get 1 minus R to the n. A is factored out, 1 minus R. That's where this is coming from. All right? Again, I just shortened it up by calling A1A. All right? Same story. So in this section over here, we're going to see that. Right? I just talked through what the notes were talking about. And hopefully, it made sense out of that. Erase all this stuff over here, and let's get to work. Right? This is me studying the material in front of you. So what do they tell me? In a progression 3, 1, 1/3 to 7 terms, find the last term in the sum. Well, let's write this down. So A1 is 3. A2 is 1. Well, I can look at that and know what the R is. What's the R? The R is 1/3. All right? So I know that much, just looking at that first term, the first two terms. And it certainly stands to reason. It looks like they're just multiplying by 1/3 to get to the next term. Now, you could march out if you want. What do you get? 3. Well, 3 times 1/3 is 1. 1 times 1/3 is 1/3. 1/3 times 1/3 is 1/9. 1/9 times 1/3 is 1/27. 1/27 times 1/3 is 1/81. 1/3 times 1/81 is 1/243. And this would be A1, A2, A3, A4, A5, A6, A7. So I know A7. I just counted out there. That's all I've done. Now, someone said I'd rather use a formula. Me too. Let's write that down. A7 would be A1, which is 3, times R, which is 1/3, to the 6th power. What does it give you? A7 would be 1. Well, 3 to the 6, and 3 on top would be 3 to the 5. What's 3 to the 5? Let's go through it. 3 times 3 is 9, 27, 81, 243. That was pretty easy. We get the same result. What do they want to do? They want to get the sum. All right? I think it's pretty easy to do that. What sum do they want? The sum of these terms over here. Now, I'll be honest with you. You could add them together. And what would you do? 3 plus 1 plus 1/3. Whoops. Plus 1/9. Plus 1/27. Plus 1/81. Plus 1/243. I'm not opposed to it. All right? If you want to do that, you can. What's common denominator? Well, that seems a lot of work for me. It's 243, and I got to do all kind of arithmetic, and I want to avoid that if I can. So let me just say, I don't want to do that, but you can do it if you want. I want to write the sum down. And what sum do I want? S7. And what do you get? 1 minus R. What's R? 1/3. Then what do you get on top? And again, the formulas are right up here. 1 minus 1/3 to the 7th power times A1, which is 3. All right? Well, I got some work to do. And someone says, do you have to do the work? Not really, but I want to do the work. So what do you get over here? Well, let's see. You would get 3 minus 1/3 to the 6th power. And the bottom is 1 minus 1/3. All right? Someone said, what'd you just do there? I distributed this 3 across these two terms. That's all I've done. Now what I'm going to do is I'm going to multiply top and bottom by 3 again. And what do you get? Let's write this down. You'll get 9 minus 1/3 to the 5th power. What do you get on bottom? Let's take a look at that. If multiplying by 3, you would get 3 minus 1, which is 2. All right? It's some work now, isn't it? Now what I'm going to do, I'm going to multiply top and bottom by 3 to the 5th. And you're right, this is work. I think I did that before, though, didn't I? And what's 3 to the 5th? It's 243. So you can get 9 times 243 minus 1. And what do you get on bottom? You get 2 times 3. 243. I don't want to put that up. I'll write that down then. And again, you decide if you want to do the arithmetic or use a calculator. You make that decision. All right. I want to go through the arithmetic for you now. 9 times 243. I'll write this on the side for you. 9 times 3 is 27. 36, 37, 38. 14, 15, 16, 17. And I got to take 1 away from that, don't I? What are you going to get? 1786 over 2 times 243. Now I'm going to do 2 into 1786. 8, 16, 18. Did I make a mistake somewhere? Oh, I see it now. I made a mistake. I made the mistake over here, and I apologize for that. So 9 times 243. I don't know how I did that. 9 times 3 is 27. 36, 37, 38. 9 times 2 is 18. I forgot to do the 3, I guess. I don't know what I did. 18, 19, 21. 2187. Take away 1 is 2186. I got to divide 2186 by 2. That would be 1. You get a 2. You get a 1 there, a 0. You get an 8, which is 9. And then you get 18, and you get 6 and 3. So what do you get? I canceled this off. You get 1,093. So you get 1,093 over 243. So that's what we got over there. All right, let's do the next one. Again, I know my scratch work is bleeding into the other work there. It says in a progression. This is geometric, by the way. And so how do you know that? Look at it. You get -2 to 6. Looks like you're multiplying by a common ratio of, and I'll write that down for you for number 2. Looks like the ratio is going to be -3. Let me see if that's true. -2 times -3 is 6. 6 times -3 is -18. And they want me to go out 8 terms. I don't want to, count the 8 terms out. I'm just going to write this down then. So I'll write it down. So what they want A8, right? What's A8 going to be? A1. Well, A1 is -2. And then I got to take that R -3 and raise it to 8 minus 1 or 7. All right? Wow. It's going to be a positive number. I know that much. All right? And I got to do 7 to the 3rd power. Well, I'm going to say 3 to the 5th power. I just did that before, right? That's 243 times 3 squared. Let me write that down. Did we just do 9 times 243? We sure did. 2187. All right? And then what do I have to do? I have to multiply it by -2. I'm sorry, by 2. Let me put that down for you. And 2 times 2187. 2 times 7 is 14. Let's see. 2 times 8 is 16, 17. 2, 3, and then 4. 4, 3, 7, 4. That's done. All right, it's right over here. Let's put down the next thing they asked for, the S8. And let's write this down. So it's going to be 1 minus R, which is -3. And then what do you get? You're going to get 1 minus -3 to the 8th power times A1, which is -2, right? I got to do that arithmetic. And the bottom, what do you get? You get 1 minus a -3, which is 4. And then you get a -2 there. So let me write this down. S8. You get -2 over 4, which is -1/2. Now I got to do this nightmare. But I've already done, 3 to the 7th, right? And that turned out to be this nasty number there. Just got to multiply by another 3. Let me put this one down for you. I'll be careful too. 2187 times 3. And what do you get there? Let's take a look. 3 times 7 is 21. 3 times 8 is 24, 25, 26. 3, 4, 5, and 6. All right? But I want to point out it's a negative number raised to a power. So that's not that bad. So you can get 1 minus that number now. And that number is 6561. All right, I got to do the arithmetic now. S8 is going to be -1/2 times minus 6560. Well, that's a positive number, right? Let's do this over here. 2 into 6560. 3. And then you're going to get 6. 5 comes down. 2. You get a 4. 2 times 4. You get 1. 6. 8. 32880. All right, feel pretty good about that. Got them all. All right, so let's take a look at what we have to do next. And this is the part where, I would say really the majority amount of your work really goes in the exercises. Right? He gave you some examples and some written material to read through. You go through the exercise. It really kind of reflects what he's done. I did every single exercise. Yep, it took me time and effort to get through it. It's manageable. You can do it. There's a short section. And then you get to the SAGE code over here. What's SAGE? Computer Algebra System. CAS for short. It's open source software, meaning free to download. Free to download, like I said. Or you can do the interactive web-based application. And you'll see some code there to put in if you like. Okay, I'm also going to point out our real intent here is to get you to do the problems as Wells has designed you to do those problems. What does that mean? You do these problems over here. And again, if you have trouble with any of these problems, please email me. Let me know that. Tell me you're in section 78.3 and you're working problem number 8. Don't give me the page number because I can change. And I'll work through the problem. And then see if I made a mistake, I'll certainly hold myself accountable and correct it. And I'll give you credit. And I would really appreciate it if you'd do that for me. Thank you.